Okay, so yesterday we started talking about the reduced row echelon form and just the row echelon form. So for the first example, we put it in row echelon form. If it's in row echelon form, you're going to use back substitution to find your x, y, and z. If you put it in reduced row echelon form, what you're going to see is you can tell what x, y, and z are right away. Okay, so that's what we're going to do with this. Now, if you have row echelon form, you already have this format here. Okay, this would be the row echelon form. And then we're going to work our way to the reduced row echelon form. So the main difference between them is what? Do you guys remember that from yesterday? Okay, yeah, so this one has the zeros above it. So in reduced row echelon form, you'll have a zero above every leading one. And so we're going to take our first example and we are going to put this in reduced row echelon form. So we got here on the first example. Now, if you're doing this like on a homework problem, you're not going to do both. You're not going to solve it with row echelon form and then go to reduced row echelon form. You would just do one or the other, okay? So if we want to do reduced row, we have to make those numbers that I've circled into zeros. All right, and then we talked about which one you want to start with. So we're going to make the 2 into a 0 first. Do you guys remember what row I said you had to use? 2. Yeah, so you're going to use the row below it, and do you guys remember the reason why? Yeah, so when you add them together, since you have a 0 here, then you're going to add it to the 1, and that won't change anything. So we're going to multiply the second row by -2. We're going to add it to row 1, and then that's going to replace row 1. Okay, and if you already have this written down, you can just follow me as I'm going along with it. So -2 times 0 is 0. 0 plus 1 is going to be 1. Oh, and sometimes what I'll do is I know I'm only going to be switching row 1, so then I like to put in my other 2 rows. Okay, so I know exactly where they're going. So if you do -2 times 1, you'll get, yep, and then when you add it to 2, you'll get 0.
So is it just going to be a variable that makes it 0?
Yep, it'll be, yep, whatever the opposite of this circled term is. Okay, and then we still have to keep going, so -2 times 4 is -8. -8 plus -1 is going to be -9. And then -2 times -3 is 6. 6 plus 2 is going to be 8. Okay, so now what we need to do, we still need to make these 2 our zeros. And what I would do is, well, really, you could do them both at the same time if you wanted. Do you guys want to try that?
Let's just do the basic one.
Okay, so you're always going to take the row that's below it. So because you have this circled 4, the row that's below it is going to be row 3, okay? And the reason why you want to use row 3 is because, look, it starts with 2 zeros. So if it starts with 2 zeros, when you add it to the top, it's going to stay. It's not going to change any of the work you've already done. Okay? So if I want to change the 4 to a 0, yeah, exactly. So you're going to do -4 times row 3. We're going to add that to row 2, and that's going to be our new row 2. Okay? And I know you guys are nervous about doing 2 at the same time, but I really feel like you can do it. Okay? So I would also okay, so then you're gonna use the third row.
Does this only apply when you're thinking of reduced row echelon form? Does it also apply for row echelon?
No, this is just gonna be for reduced row because, you're gonna be doing the zeros. Yeah, then,
Is reduced row echelon form basically like the 18th echelon form? So like anything that you can write in echelon form, you can also write in reduced echelon form.
yeah, yeah. You should be able to write every matrix in that form if you're solving it, if you're solving the matrix. Okay, so, alright, the last row is gonna stay the same, so first let's do row 2. So this is -4 times row 3, which is 0, and then 0 plus 0 is gonna be 0. So see how that doesn't change the work that we just did? Same thing with this, -4 times 0 is 0, 0 plus 1 is gonna be 1. -4 times, 1 is -4, -4 plus 4 is gonna be 0, and then -4 times -2 is 8, 8 plus -3 is 5. Alright, and then, this part we did not do yesterday, right? Okay, so, oh, that's why you guys wanted to do it in 2 steps, because we just did the 1 step yesterday. Okay, so if we do the 2 steps, I'm gonna show you how to do that on here. Since you already have that 1 step done, you can just go ahead and on your notes, you can put it like this. So 9R3 plus R1, and that's gonna replace R1, and then you can put your new matrix. Okay, and your new matrix is gonna change row 1. Okay, so now I'm gonna do 9 times row 3. Again, these are nice because they're both gonna be 0. So when you add them, right, 0 plus 1 is still gonna be 1, 0 plus 0 is still gonna be 0, and then the next one is what we wanted, right? 9 plus -9 to get to 0, and then we have to do just some arithmetic for the last one. So 9 times row 3, so 9 times -2 is -18, and then -18 plus 8. Okay, great. So now we're in reduced row echelon form. And let's see what this matrix is telling us. Okay, so remember, this column is for all the x's, this is for all the y's, this is for all the z's, and these are going to be your constants. So in this row, I have z is equal to what? -2. In this row, I have y is equal to 5. And then in my top, I have x is equal to -10. So then this is my solution.
After you got to this point where you were in row echelon form, couldn't you just solve and then put it back in reduced row echelon form?
Well, right. That's why you wouldn't do both of them. Okay, so if you're trying to just solve the system, you could stop at row echelon form and solve the system with back substitution, or you could keep going until you get to reduce row echelon form, and then the solving your system, you wouldn't have to do back substitution. You just have x equals y equals z equals. So, like on your homework, if there's a question that says that you need to put it in reduced row echelon form, you have to show me with your row operations how you got there. Yes. What do you mean? What do you mean?
Reduce row echelon form, you solve every system that way.
That.
Will some of the work that they
No, you should be able to put it in reduced row echelon form. Dan?
Are there like multiple ways I can answer these, or are there certain rules that you have to follow?
Okay, so your final answer is going to be the same, but the steps that you take could be different, just depending on how you're looking at that. Now, when you're doing reduced row echelon form, like I said, I do recommend doing it so that you use the row below it. That way you don't have to worry about undoing any of the work that you did. So that you'll want to do something similar to. especially when you're doing just the row echelon form, yeah, there's gonna be many different ways that you could get there. So you can actually use matrix functions on your calculator to check your work, and I'm going to show you that today. And then, of course, we could cheat and let the calculator do all the work for us, but we aren't lazy like that, and of course, we want full credit on our homework, so you're going to use it only to check. And again, I want to stress that you are going to have 2 parts to your final test on the last day, and I'll talk to you guys a little bit more about that later today after we finish this.
What's the
So we have 2 different types of systems, inconsistent and dependent. We actually talked about these already. Do you guys remember when the system's inconsistent? Okay, yeah, so if it's inconsistent, there would be how many solutions for that? None, okay? And then if it's dependent, how many solutions would be that? Infinitely many. Okay, so all of the systems that we did had exactly 1 solution, but you could have infinitely many solutions, no solution, or just 1 solution, which we already saw. So the row echelon form of a system allows us to determine which of these cases apply. So this is just going to tell you when you're going to have these different cases, and I'm just going to highlight some parts. So if you've transferred it into row echelon form, then one of the following is true. So you could have no solution. That's going to happen when you have a row that represents an equation of 0 equals some constant c, okay, where c is not 0. So what that means is you would have an equation that is not true. Okay, so if you had, for instance, 0 equals 5, is that true? No, so then it would be inconsistent. Okay, that's what you would end up getting from the bottom. You could also have 1 solution, and that's what we just did. And you could use back substitution if it's just in row echelon form. And then the other one is going to be infinitely many solutions. And you are going to have infinitely many solutions if the variables in row echelon form are not all leading variables. And if it's inconsistent, it will have infinitely many solutions. That's called dependent. What you'll see here is sometimes you'll see a row of zeros on the bottom. And if you see a row of zeros on the bottom, like you'll have 0 equals 0. And if 0 equals 0, that's a true statement, which means you'll have infinitely many solutions.
So is any true statement? So if you were just to say
That
5 equals 5, is that an infinite?
No, here, I'll show you with these. So if it's no solution, if you look at your last row, okay, your last row, what you have is 0 equals 1. That's the equation written here. So does 0 equal 1? No, so that's why there's going to be no solution. Okay, for this one, each variable is a leading variable. So you could solve this with back substitution, right? Because z would equal 8 here. And then you have y plus 2z equals negative 2. You could solve it with back substitution. And then x plus 6y minus 1z equals 3. You could solve that with back substitution. But for the infinitely many solutions, on the bottom, you can have this row of zeros, and there's no leading variable for the z. Okay? So then you are ending up with 0 equals 0, which is a true statement, and that means there are going to be infinitely many solutions to your matrix.
What if you're given a matrix because you want to solve it, but it's 0 equals 5 and then it has 0 equals 0?
You shouldn't have both of those. Yeah. If you had both of them, if you had something that wasn't true, then there would be no solution. So a lot of times matrices are used for coding. So you can use them in different firewalls to protect. And then if you could solve the matrix, then you would be able to unlock the system. So obviously, if you're creating a matrix, you definitely don't want to have an infinitely many solution matrix, because then your system would be easily accessible. So we're doing small matrices, but matrices can be as many rows and as many columns as you want. So the bigger your matrix is, the harder it is to crack that code.
Just how to hack that.
No, but we can. All right, so for 10-3, I asked you to just start your homework. We're gonna start some of 10.4, and I am gonna show you on the calculator how you